Good morning, class, or good afternoon to the other sections. Now we are going to conduct our experiment on aldehydes and ketones. So, at this moment, we will be doing the different tests that I have discussed to you during the lecture. First is we are going to conduct the miscibility test of aldehydes and ketones. But before that, I would like to introduce to you the different tests that we are going to undertake after the miscibility test. So, the chemical reactions that takes place with aldehydes and ketones will determine the different reactions involved when these aldehydes and ketones will undergo reactions with different substances. So, first, we have what we call as oxidation reactions. Now, in oxidation reaction, we involve different types of oxidizing agents. So, to begin with, we shall be conducting tests according to an oxidizing agent. Here, in the first one, we have the Tollens test reagent, wherein this is a test for the reducing property of aldehydes. Okay, so we are using here an silver ammonia complex as our Tollens reagent. Then it normally oxidizes our aldehydes into carboxylic acid. Okay, so we expect that with Tollens test, the possibility or the positive test for Tollens test is the preparation or the deposition of metallic silver, okay, out of the reaction between our aldehydes. Okay, so we have even the benzaldehyde in order to form a silver or metallic silver as our reduced product. So therefore, our oxidized product is the salt of carboxylic acid. Okay. So, once again, our positive test result is the deposition of a metallic silver along the sides of our test tube. Second, another oxidizing agent that we are going to use is the Fillings reagent. So, what is the Fillings reagent? So, this is ultimately a cupric ion, which is blue. So, if you notice, it is blue in color, which contains cupric. And reaction with aldehydes, because this is a test for the detection of aldehyde. So, therefore, any other substances, just like acetone, okay, or even the aromatic aldehydes, will not be conduct a positive reaction between the Fillings test and the aldehyde itself. So this is only for the detection of acetaldehyde. Okay, so Fillings reagent is a cupric ion, but once it reacts with acetaldehydes, the cupric will be reduced into cuprose. Okay, so a positive result for Fillings test will be the deposition of a brick red precipitate of cuprous oxide. So, what is the formula for cuprous oxide? This is Cu2O. So, therefore, we have from reduction from cupric to cuprous, from Cu plus 2 to Cu plus 1 ion of copper. Okay? But the deposited or the precipitated product is cuprous oxide, which is brick red precipitate, and the solution on top is still blue in color. Okay, so therefore, once again, our product or our oxidized product, since this is a reduced or cuprous oxide is a reduced product, our oxidized product is also a salt of carboxylic acid. Okay, so therefore, these two reagents will not pose a positive effect or a positive reaction with ketones. Okay, once again, our tolerance test is a test for the reducing property of aldehydes, just like aliphatic or aromatic aldehydes. But our Fehling's reagent, which is a cupric ion, then it is only for the oxidation of acetaldehyde. Okay, no other one. Then we have the third reagent that we use, or third test for the oxidation process. We are using potassium dichromate, just like what we have discussed in our lecture, no? So we make use of potassium dichromate, which is orange in color, and you remember that in your alcohols and phenols, because we have in the oxidation of alcohols, primary alcohols and secondary alcohols. So primary alcohols will yield an aldehyde, while secondary alcohols will yield ketones. However, for primary alcohols, it will take a two-step process wherein the final product would be carboxylic acid. So eventually, the oxidation of aldehyde will yield a final product of carboxylic acid. And once again, our oxidized product is carboxylic acid, and the reduced product is chromic oxide, which is the conversion of the dichromate, which is chromium, hexavalent chromium, the Cr plus 6, to chromic, which is Cr plus 3. Okay, so this is our oxidized or reduced product, chromic oxide. And what is the color? So the color or positive test would be blue-green solution. So since both aldehyde and ketones are positive to oxidation with potassium dichromate, so therefore they will both result to the formation of a blue-green solution. Okay, so what will be its effect also when we have the aromatic hydrocarbon, or when we have what we call as aromatic alcohol or phenol? Okay, so based on our or even what we call as C6H5OH, our phenol. So last time we have a positive effect, but it will, even if it will generate a blue-green solution, but still it will generate a different reaction or a different product, which is benzoquinone. Okay, and yet another blue-green solution of chromic oxide. Okay, so our next activity or next oxidizing agent that we are going to use is the DNP test, which means this is a reagent containing the 2,4-dinitrophenylhydrazine. Okay, dinitrophenylhydrazine. And in order to take effect with this experiment, we are adding the DNP test, okay, reagent. And once again, the DNP test reagent is, or DNP test, is also what we call as Brady's test, no? Brady, B-R-A-D-Y. Okay, so it contains a what we call as 2,4-dinitrophenylhydrazine, and take note of the color. This is yellow in color, and then with the addition of glacial acetic acid and of course saturated sodium chloride here. So ako ni siyang lain-laino na. So these are our reagents, no? So 1, 2, 3, 4, and 5. So in the DNP test, so we expect that a positive result for the DNP will generate a bright yellow or orange precipitate. And what is that precipitate? That will be a precipitate of 2,4-dinitrophenylhydrazone. Diilisan lang ang atong zine, which is I, into O. So we have 2,4-dinitrophenylhydrazine, is our oxidizing agent, and our reduced product will be the 2,4-dinitrophenyl hydrazone. Okay, now our last test is what we call as iodoform. By the way, so what is an indication of using the Brady's test or dinitrophenyl hydrazine test? So these are mostly positive to aldehydes and ketones. Okay, so therefore, we expect that a chemical reaction will take place between DNP and aldehydes as well as ketone. So if we have here in your lab manual or lab guide, you have there acetaldehyde, acetone, benzaldehyde, ethanol, the tert-butyl alcohol, and then you have a blank of water. So therefore, we expect that with DNP, we expect that a bright yellow or orange precipitate will be observed. Okay, our last oxidation reaction would be the iodoform test. Okay, so iodoform here is only intended for the reaction of what you call this one? This is only intended for acetaldehyde and methyl ketones, no? Just like your acetone. So once again, iodoform test can only be used for the detection of acetaldehyde and methyl ketone, or the what you call as acetone. Okay, so what do you expect? So an iodoform is a deposited or a precipitated substance which is yellow in color, a yellow solid substance, which is what we call as iodoform. So the formula of iodoform is CHI3, or merely we call it as triiodomethane, okay, or CHI3. So these are the different oxidation processes that we are going to undertake for the different aldehydes, ketones, as well as comparative test for ethanol and the tert-butyl alcohol, which is our tertiary alcohol, as well as water. Now take note, we have already, some of this, we have already tested this in experiment number 2 for organic compounds, which is alcohols and phenols. Now we will be repeating some of this because in our primary alcohol, we normally see there that there is a reduction or there is a reaction between our experiment on ethanol with an oxidizing agent, which is potassium dichromate. So we try to expect that it will also result to the same reaction. Okay, so we begin, okay, by having our substances of alcohols, or rather aldehydes and ketones, okay, for the miscibility test with water. Okay, so therefore our reactant here, or it will undergo now a reaction. Will it undergo a reaction with water, or will it be miscible in water? So therefore, you have in your lab guide test tubes 1 to 5, which includes test tube 1, we have formaldehyde, okay. So ato sa ning hipuson, okay, so we will be conducting our first experiment using this different aldehydes and ketones. Okay, so we have here in test tube number 1, we have the, what is this? Formaldehyde. Okay, so it means you have the 1 carbon atom. So we have HCHO or C double bond O H2. Okay, then we have the acetaldehyde, which contains 2 carbon atoms, which contains a carbonyl group, and then we have an acetone, which is CH3, C double bond O and CH3. Then we have the benzaldehyde, which is C6, an aromatic aldehyde, C6H5CHO or C double bond O and then an H. And lastly, we have the acetophenone, which is a common name for methyl phenyl ketone. Okay? So the common name is both the same, acetophenone and methyl phenyl ketone. Okay? So we'll take a sample of these reagents. Okay? So we take a sample of these reagents into each of the test tubes. So we have 5 and then we add it with water. So you have to determine what will happen. Ilan na ito? 1 ml of the solution, each of the solution. Okay, and then the same amount of volume of our tubig. Isa pa ka-dropper. So we will have 1 ml of each of these formaldehyde, acetaldehyde, acetone, benzaldehyde, and acetophenone, or we call this as methyl phenyl ketone. Okay, so we have 1 ml each. Ay, sayot. So we'll have 1 ml each of our substance. We have the third test tube. We have acetone. Wala din na itong ilibili.
Ato lang iba yung 1, 2, 3, 4, 5.
Okay, sige. Okay, so we are going to label each of these test tube. So kani ang 1.
Kana.
Sorry.
Pero sunod ani identify na nato cell ang kuan cell ang sa oxidation i-identify na nato cell sa oxidation di na ta magamit og number
Name.
kay pareha man siya tanan og dili man siya tanan magamit nato lain na pod Okay, so we have here the labels of our substances, aldehydes and ketones, according to in order. So our number 1 here is formaldehyde. Number 2 here is acetaldehyde. Number 3 is acetone. Number 4 is benzaldehyde. And number 5 is acetophenone. Okay? So number 5 is acetophenone. Now I'm going to test this one with the same volume of water. So what are you going to do here is to observe if we will be generating a colorless color or whatever color that will be developed. So we have here for water and formaldehyde. Okay? Dili makita. Ay!
Yan test mo, miss. Or patumay yun.
Dili, kaya di ko siya makita. Okay? So, kana siya. We have here our formaldehyde and water. And then, another next one is with acetaldehyde and water. Okay? Take note of the color. And then, we also have the acetone and water. Okay? And then we have benzaldehyde and water. Okay? So take note of that. What happened? Okay, we will shake that one later. And then we have acetophenone and water. Okay, so take a look. We'll take a look. So this is the result of our formaldehyde and water. Okay? So if you notice, everything dissolved. So they are miscible in water. Okay? Formaldehyde and water. So they are miscible with each other. Next, we have our next one is acetaldehyde. Okay, acetaldehyde. So what do you think? So we have here atay black. Okay, so we did not have any color or layer form, so therefore they dissolve or miscible in water. Now we have the acetone. Okay, just the same acetone. Okay, so try to look at that. So acetone also dissolved in water or miscible in water. Okay, and then we have benzaldehyde. Okay, so try to look at what results with benzaldehyde and water. So what do you think? So it forms layer, no? This is benzaldehyde and water. Okay? Tempa. So it forms layer. So what do you think? Kay tungod pareha lang sila volume, let us try to determine akong butangan og tubig. So the more volume will be water. Okay? Para you will determine which one will sink at the bottom and which one is on top. Okay. In that case, what do you think is on top? Okay? So since water has more volume, then therefore that is water on top and the benzaldehyde is at the bottom. Okay? So they are immiscible. Okay? They are immiscible in water. Okay. So let's try to look at that. Okay, immiscible. Next, we have acetophenone. Okay, once again, how does acetophenone look like when they are in water? Okay, so there the solution or the mixture tries to separate one from the other. Okay, so try to look at that. So therefore, they are immiscible since they form layer. And once again, we'll test with another volume of water, and we'll see the number of volume of water is now increased, and therefore let us determine which one sinks at the bottom. Okay, so we'll try to look at that now. Okay, so very clear here that our acetophenone lies at the bottom and our water is on top. So therefore, acetophenone is denser than the water. Okay, so they are immiscible. Okay, now you try, because you cannot, you cannot create, or you will not be able to identify the order of this, but you try to research what will be the order of acetophenone, benzaldehyde, acetone. Of course, you know already the order of acetone, but try to know the order of formaldehyde, acetaldehyde, acetone also, what is the correct term. So when we use the term for acetone, we use normally as antiseptic odor, no? Antiseptic odor. Then we have benzaldehyde, which is actually, okay, I will just one. Okay, so the formaldehyde is the one that we are using. Okay, it is the one that we are using to preserve the cadaver, diba? Formaldehyde, or in short, we have the formalin odor, no, for formaldehyde. Acetaldehyde is normally having a chico-like odor, kanang fruity odor of chico. Okay? While acetone is somewhat antiseptic. Okay? Benzaldehyde is somewhat like fruity odor, like almond. But since I don't know about almond, okay, ambot og mao ba ni ang bahaw sa almond? Alam mo na, okay? Okay, so you are going to determine the color by researching the odor, I mean, by searching for the odor of these substances. So once again, our first substance, or number 1, is formaldehyde. Number 2, acetaldehyde. Number 3, acetone. Number 4 is benzaldehyde. And number 5 is acetophenone, which is methylphenyl ketone. Okay? So, this is our test for miscibility with water. So, we have there our first 3 test tubes are soluble in water, and you know already the reason. Okay, so the lower, or rather the presence of aldehyde, as well as the presence of aldehyde will most likely dissolve because it can undergo hydrogen bond with water, and also the same as acetone because of the electronegativity of oxygen, which can easily bond with hydrogen of water. Okay? So, that is all for miscibility. Now, we go for the oxidation test now, using the different reagents that I have introduced to you a while ago. So, we'll begin with our test tube number 6. Okay, 7, 8, 9, and 10. Okay, test tube 6, 7, 8, 9, and 10. So, we will be using, okay, we will be using asa na to? The Tollens test or oxidation test using the Tollens test or silver mirror test. Okay? Tollens test or silver mirror test. It is also an oxidation test.
Bibilan na.
Oh, nibilan.
Main.
So, acetaldehyde.
Main miss.
Acetaldehyde.
Sa talihan na kay
Then, number 2 is acetone. First test tube, we have acetaldehyde. So, pareha ra na siya tanan nga label. Pareha tanan sa all other test tubes. So, we have acetaldehyde. Oh, ay kaduha acetone. We have here acetaldehyde, and the next is acetone. And next is benzaldehyde. Ay, taas mo kaayo sa babaw. Oh, sa babaw. Acetone, then benzaldehyde, and then baan na lang ng uban nga kan ulay gamit. Ano lang siya. Acetaldehyde, acetone, benzaldehyde. Wala na ng acetophenone. Ethanol. Ethanol. Saan na to? Benzaldehyde. Katang imong gikuha ganina.
Akon?
Asa gi? Kanina taklob. And then ethanol. And then we have tert butyl alcohol. So pareha na sa uban ng mga test tube yapon.
Ngayon na ba? Tert butyl. Pwede ra siya tea lang siya. Tiyo miss.
Tea lang, tea butanol or tea. Okay. So once again, we have here our substances, our aldehydes and ketones. We have acetaldehyde, acetone, benzaldehyde, we have ethanol, and we have tert butyl alcohol. So we'll have a comparative test with Tollens test, or we call this as silver mirror test. Okay, so we'll have here 1 ml each of this reagent, and then another 1 ml for our Tollens test. Okay, so 1 ml ethanol, acetaldehyde, and then 1 ml of acetone, then 1 ml of benzaldehyde, then we have 1 ml of ethanol. Hindi naman maklaro. And then 1 ml of tert butyl alcohol. Okay. So once again, we have 1 ml of acetaldehyde, 1 ml of acetone, 1 ml of benzaldehyde, 1 ml of ethanol and 1 ml of tert butyl alcohol. And then we will subject this one to Tollens test. So, Tollens test using the same volume of Tollens reagent. Okay, so we add to our first acetaldehyde. Okay, so take note. Ay, ang atong kuan. Bunsen burn ang water bath.
Gamit burner, miss.
Oh.
Silver meron.
Okay, and then we have acetone. And then we have benzaldehyde. Okay. So we have ethanol plus 1 ml of Tollens reagent. And then we have tert butyl alcohol. Okay? So we'll shake this and then we'll subject this to a hot bath. Wala lagi siya gibutang diri no ihat ba. Warm in water bath. So we're gonna warm this in a water bath, okay? And observe whether it will generate a different color and will it result to a precipitation. Okay? So we have benzaldehyde. We will shake this one first. So once again, what will be expected from this test? So this is a test, or the Tollens test is again a test for the reducing property of aldehydes. So therefore, we expect that we have aldehydes here that will generate a silver mirror observation, no, of a silver mirror or metallic silver deposited along the sides of the test tube. Okay, so while waiting for our substance, okay, while waiting for our substance, we move on to our next test, which is fillings test. Okay? Hala? Asa naman to? Wala pa tayo dito pa. Kailangan dito. Label for the same, ano. Okay, for a while, class.
Same ano naman?
The same name. Maya lang. So, so we have acetaldehyde. Kalusod ba na ano yung mag-gloves ka?
Maulan hindi tayo
Acid. acetone.
Aldehydes.
Naunaan na lang ng mga bata naman. Tanda mo yung experiment. May stick pa kay si ma'am. Aldehydes. Ethanol. 30 lang. Okay. Oh, sige.
Alam niyo siya ba?
Ah. Okay, here. So we have once again, our second test will be using the oxidizing agent, which is filling solution or fillings reagent. Okay, so we have fillings reagent, and this is intended also for the detection of acetaldehyde. Okay, only for the detection of acetaldehyde. So fillings, again, fillings reagent is a deep blue solution containing cupric ion, and cupric ion will be reduced to cuprous ion when it reacts with acetaldehyde. So therefore, we'll have the same volume of 1 ml of acetaldehyde, and then 1 ml of acetone, 1 ml of benzaldehyde, and then 1 ml of ethanol, and 1 ml of third butyl alcohol or tertiary butanol. Okay? So, take note of the color development once I have it reacted with our fillings reagent. Okay? Once again, our fillings reagent is a cupric ion. Okay? So, take note. Okay? That is acetaldehyde. And then we have acetone. I-warm, kung warm na siya.
Ilan kayo?
Okay, so take note of the color development before we subject them to hot water bath. Okay? So before we subject them to water bath. So we're gonna shake. This is our acetaldehyde with fillings reagent, our acetone with fillings reagent, and our benzaldehyde with fillings reagent, our ethanol with fillings reagent, and also our tert butyl alcohol with fillings reagent. Now take note that the positive test for this is the formation of a brick red precipitate. Okay? So we will allow this to undergo to a warm bath under a water bath.
Miss, hindi na miss.
Okay.
Kaning lima miss.
Oh, kanipud.
Okay, sir. Tara ang file na.
Okay. So next, we shall conduct, while waiting for our test tubes to undergo a warm heating, then we will proceed with our third test, oxidation test using potassium dichromate and dilute sulfuric acid. So we have here our potassium dichromate and dilute sulfuric acid. Okay? So our oxidizing agent is potassium dichromate and with our catalyst dilute sulfuric acid. And once again, we will now add our substances, our solution, 1 ml of which, and then